As has been previously discussed, there are three control structures used in programs: sequence, selection, and repetition. The programs written so far have mainly used sequence and selection. Most programs, however, also use the repetition structure. The repetition structure directs the computer to repeat one or more instructions until a condition is met. This repetition structure, also called looping or iteration, tells the computer to repeat one or more instructions until a specific number of times or until some condition referred to as the loop condition is met. There are three basic forms available to the C programmer: the while loop, the do-while loop, and the for loop. The first of these conditions that we'll discuss is the while loop. The while loop is referred to as a pretest loop because the condition being checked for is at the top of the loop. The key word is while. With the while loop, you can place one statement without braces or multiple statements inside of braces to be executed over and over until this condition, whatever that condition might be, is met. Of course, this condition needs to be phrased so it can be answered with a true or false result. This loop condition can contain variables, constants, functions, mathematical operators, relational operators, and logical operators. The while loop is a pretest or top-driven loop. This simply means that the loop evaluates the loop condition before processing any of the instructions within the loop. If the loop condition evaluates to true, then the loop instructions are processed until the loop condition evaluates to false, at which time C stops the processing of the loop. Processing then continues with the statement immediately following the end of the loop. Depending on the loop condition, the instructions in a while loop may not be processed at all. For example, if the loop condition evaluates initially to false, then the compiler skips the instructions within the loop and processing then continues with the first statement following the end of the loop. We will look at some examples of while loops shortly. The second looping structure we'll take an overview of is the do-while loop. As with the while loop, you can use the do-while loop to repeat one or more statements either a specific number of times or while some loop condition is true. However, unlike the while loop, which evaluates the loop condition before processing the loop instructions, the do-while loop evaluates the loop condition after first processing the loop instructions. Therefore, the do-while loop is called a post-test or bottom-driven loop. You will note that the condition is at the bottom of the loop, and you can execute one or more statements within a block or simply one statement without the block. The syntax of the do-while loop begins with the word do, followed by the body of the loop, which contains one or more statements you want to repeat. The do-while loop ends with the word while. Do and while are the key words. As with the while loop, the do-while loop condition must be enclosed in parentheses, and it must result in a either true or false condition. The loop condition determines whether the instructions in the body of the loop are processed. Like the loop condition used in the while statement, the do-while loop can contain variables, constants, functions, mathematical operators, relational operators, and logical operators. Since the do-while loop is a post-test loop, that is, that it evaluates the loop condition after first processing the instructions within the loop, the do-while loop always processes the loop instructions at least once. After the first time, however, the do-while loop instructions will be processed only when the loop condition evaluates to true. In both cases, with the while loop and the do-while loop, statements will end with a semicolon whether they are in the braces or not. Note that there is also a semicolon at the end of the while condition with the do-while loop. There is not, however, a semicolon after the word do. The third looping structure is a for loop. The key word is the word for. This is quite different than the previous two loops that we've discussed. This looping structure is commonly referred to as a counter control loop because it uses a counter to control the number of times the loop is processed. Although you can use the while and do-while statements to implement a counter control loop, the for statement allows you to code the loop in a more convenient and compact manner. The syntax of the for statement begins with the for clause, followed by the body of the loop. The body of the loop can be one statement, or, as you see in the second example, a block of statements enclosed in the braces. If only one statement is being repeated, then end that statement with a semicolon. A block of statements also will be enclosed in the braces, but they will also end with semicolons individually. You will note that the for clause used to code a counter control loop requires 3 items of information enclosed in parentheses and separated by 2 semicolons. The first item specifies the data type, name, and initial value of the counter variable. That is, the variable that the for loop will use to keep track of the number of times the loop instructions are processed. The data type must be a valid C numeric data type. Character or string variables cannot be used with the for loop as its variable. This start value can be a number that is either positive or negative, an integer or non-integer. The condition in the for clause specifies a requirement that the counter variable must meet before the loop instructions are processed. If the loop condition evaluates to true, the loop instructions are processed and the next task is performed. Otherwise, the loop stops. The third component, the update expression, tells the loop how much to add to or subtract from the counter variable each time the loop is processed. This is what will allow the loop to continue by either adding or subtracting from the initial value and then from the previous values as the loop executes. All 3 of these looping structures has a purpose, and we will look at examples of each of these in some sample programs.